Hello everyone, welcome to our session, Knowledge Graph-Driven Feedback Loops to Optimize TikTok Shop Video Marketing.
So Taeyang Kim is a dynamic machine learning engineer and a computer scientist with a passion for innovation and a track record of excellence in the field of data science and artificial intelligence. His contributions have not only advanced technologies within his organizations, but have also set the stage for future innovations in the industry.
David Fagerburg is a highly motivated software engineer with a passion for learning and helping others grow. David has worked at Pattern as a senior software engineer and has led and contributed to the development of internal applications to streamline the e-commerce acceleration platform that Pattern provides. So the rise of TikTok Shop marketing has been very interesting to our company as an e-commerce accelerator leader. We have been investing a lot in Amazon, Walmart, or Tmall, or any other like 20 different world marketplaces. But TikTok Shop has been growing recently a lot. When considering the 2021, it was about approximately $1 billion GMV. So GMV is the gross merchandise value. And it was projected to grow a lot. And this year it is projecting to be $66 billion, and which is like 6,500% growth. And as you can see in the other chart, like TikTok is a rising force in social e-commerce, like social buyers buy platforms in millions. You can see that it's growing just right next to the Instagram. And on the other graphs, you can see that even just over 1 year, the growth is like about 140% for the marketplace, that our company has been like trying to figure out how to optimize this marketplace. And the cost of TikTok Shop, moving products on TTS. So TTS is like TikTok Shop. From now you can assume it, and it's very expensive. So it has a lot of like costs. So you first need to send samples to the TikTok shops. So many TikTok shop affiliates like expect to be like send a sample product for free. So before recording and posting promotional content, or even taking on any binding obligation to actually create the content. And also the payment for created content. So affiliates are often paid a commission based on the GMV or units sold for a given shoppable video, in addition to affiliate rate often charged for initial posting of the content. And creator briefs and creator review. Getting affiliates to create content that helps and aligns with a brand's image and perception is complex. Lots of efforts goes into creating guidelines to share about talking points, claims to make or not to make, etc. Let alone ensuring content follows those guidelines. So they have a lot of costs involved in with the TikTok shop. So even after you're doing all the right things, sometimes it falls flat. So you have a kind of possibility of like winning the algorithm lottery. Like typical cost per clicks models for advertising are safer because they guarantee you will get the number of impressions you pay for. Create something once that works, spend enough to validate on expected conversion rate, and then scale it as far as you need or want. TTS, which is like TikTok Shop, again, affiliate content spend is riskier as well. There's no promise that investing in a video will get you any amount of views at all. And if you wait to find something that you can validate, by the time you get more budget allocated, it may be stale or worse, or spamming the same thing over and over will ruin the authenticity. TikTok Shop recommends hundreds of unique videos in the first 30 days for a successful product launch. And of course, it would be very difficult for a company to begin that kind of hundreds of unique videos at first to begin with. So what went wrong? Like many different things can go wrong on TikTok Shops. Like highlight the wrong features to the wrong audiences. If you don't find the perfect sweet spot for product market fit or product audience fit, and the video doesn't get good engagement, the algorithm will pick up on that and stop recommending your video. And it is very hard to get back to that algorithm again. And didn't immediately catch viewers' attention. If you forgot the hook, use a hook that doesn't connect the audience the video is shown to, people will immediately scroll away from the video, and the algorithm notices as well. Use the wrong affiliates for the category or product, TikTok viewers will immediately flag it as inauthentic. It will not only damage their view of your brand, but the creator's brand as well. They won't engage in a helpful way. And so it's like very important to see what's the measurable success with it. TikTok Shop provides different GMV and units sold attributions for every shoppable video. So attribution-wise, since TikTok Shop purchases are in-app purchases, direct attributions for ads watched but not clicked on can be measured precisely. So this is very important when you're building on the GraphDB as well. And measurable direct contents leads to GMV and sales relationships. And what tends to create successful videos? We can examine the individual videos, measure exactly how successful they are, and then make informed decisions. Now I will send time to David.
Yeah, so like Taeyang just highlighted, we do have some very nice measurable metrics that we can use to actually track real success. We're not stuck on just using purely vanity metrics like likes and shares and follows. We do get to actually analyze real GMV, real units sold on TikTok. So let's narrow this down with all the things that can go wrong. We could have the wrong audience, we could have the wrong hook, we could have the wrong affiliates. Let's narrow this down for now to just talking about picking out the right audience that your product appeals to and how we're going to target to that audience. All right, so let's take the example of one video. Maybe it starts out with something like, hey moms, I found the best stain remover for you to use on your car. And then it goes into a demonstration of a stain remover product or something like that. Say for that video, we want to know, all right, who is this creator targeting with this affiliate post? So she starts out by saying moms, right? So we know this is a mom that she's trying to talk to. So that's our first thing about our target audience. She calls out that it's a stain remover. That's about the product. So we're not going to pay attention to that as much yet. And then she says it's the best stain remover for your car. So she's targeting people who either own, lease, or rent a car, people who drive a car with their kids and probably have a lot of stains. So we can break up a couple of different independent facts about the target audience of this video right here. We know it's mom, owns a car, needs a stain remover for that car, so probably has messy kids or something like that. And we could go through the rest of the video probably and look at maybe get a couple other facts about the target audience. And then say we analyze a couple hundred more videos. Maybe mom pops up in another video, but they say mothers, or maybe car ownership pops up again, but it's just referenced by, like, it shows up in the frame of the video. And so we're relying on like computer vision to detect that there's a car that someone probably owns. Right, so we can take this approach of breaking down the individual facts about a target audience for a video. And then we want to deduplicate. We want to normalize or standardize a list of facts about an audience across many videos. That way we can look at this in aggregate. So once we do that, once we've deduplicated it, we have GMV and units sold from TikTok Shop that can be directly attributed to specific target audiences, right, through that video, because we know this video sells this product. We know we've inferred that they're targeting a certain audience, and we know that they sold X amount to that target audience. And we're just making an assumption here. Whoever they sold to is whoever they targeted it towards. And that's not always going to be true, but for the purposes of let's try to find the right people to target, if they buy on a targeted video, then it's close enough. All right, so we can aggregate the audience data like this. It tells us a couple of things about whichever product we're talking about here. We know the product is associated with each video. We know the category of that product because it's our product that we put on TikTok Shop, right? We know the content of the video, which we can either get a transcript from like a Whisper transcription model or something. We can do computer vision. We can do all kinds of analysis to really understand exactly what's in that video. And then we also know the relevant monetary performance of every single video. An important thing for this, TikTok Shop actually, if you post a product and you have affiliates posting for you, you will get analytics for every video that is posted by an affiliate for one of your products. So that means you sign a new affiliate, they post something, it automatically connects through TikTok's API, and you can pull the GMV and the units sold, the likes, shares, everything for that video, engagement data. You get all of that as long as it's your product that you've posted on TikTok Shop. So we get all of this for anything that is one of our products, right? We can then infer through our transcript analysis, through our computer vision, who's the target audience, and what is our standardized or normalized list of audiences across a large set of videos. And what we can take away from this is, hey, maybe this product is doing very poorly with audiences who have this one certain fact. Like maybe this product isn't connecting with moms right now. Maybe we know the same product does really well with audiences with a different fact. Like maybe it's connecting really well with dads, but not moms. And we can look at other facets of the video and say, hey, the things that seem to be moving more GMV than other things are these lists of things. And the things that work with a particular audience are these other facets of the video. So we can pull all kinds of interesting data from just analyzing the relationships between videos, different aspects of the video, and the GMV and units sold that we get along with that. So you can do this in a relational database, right? If the only tool that you have is a hammer, then every problem looks like a nail. And most people are most familiar with a relational database. If you were to do this, you have a lot of joins here. This is an example of a real relational query that we were using as kind of a proof of concept. You can see we have to join a video onto a profile for an audience, and then we have that audience has facts. Those facts are linked to normalized or standardized facts, and we have to do all these joins. This is really slow. Okay, guys, like this is so slow. If you're handing this to a marketing team who is kind of in charge of your content strategy, they pull up a dashboard and they run something in their dashboard that has to run this query right here. And it takes 3 minutes to run on only a couple of weeks of data. Like we're talking in the hundreds of thousands of rows on a facts table. 3 minutes to run because it's doing all these joins, it's doing all of these aggregations, very computationally expensive. So you could approach this a couple ways to try to fix that latency from the user experience. You could say, all right, let's store this in a denormalized schema. Let's just do all of these joins ahead of time. And then they query a table that just has everything in every row and do the aggregations there. You could pre-compute the aggregations. If you pre-compute all the aggregations, then as soon as they change what these videos are, you have to redo it from scratch. Like say they're interested in a different product. Say a marketing person just wants to exclude one video that he thinks is throwing off the whole thing. Now you have to recompute it all again. And so you're not actually able to anticipate the right things, the right way to denormalize this data for an analytics query to be performant in a relational database. And you're locked into one schema without running migrations on your database or other schema changes. It gets the time required for this adds up pretty quickly, right? So if only there is a database built for join-like operations, right? Neo4j and graph databases in general, it materializes relationships as the first class data point on any given node. And so instead of a join being, all right, we're going to look up this other table, we're going to find rows that have a certain foreign key value, we're going to match them up and do a bunch of filtering and comparing, like you would do in a relational database or a transactional relational database. Now all you have to do is just look at the relationship. It'll tell you, hey, it's stored right there. this node that I have a relationship to is stored right there. And you just go there. It's an O1 operation to look at the related node and the relationship between those nodes. Right? And then we also have a much more flexible schema to pivot to other video attributes. Say, for example, we wanted to start looking at video hooks, right? Like the first 6 seconds of a video, you got to do something to catch the attention of the viewers. If that doesn't work, like Taeyang pointed out, the algorithm is just going to stop recommending your video to anyone. And the only way to get more views is going to be spending ad money on that video, which you don't know if that video is worth spending ad money on because it never got enough views to validate anything. So hooks, very important. Say you want to know, hey, which hooks are driving the most GMV? In a relational database, if we come back to this, you got to add a new profile type for hooks. We got to add normalized hooks to our schema. We got to add just unnormalized hooks. And you've got a whole migration with like a couple new tables. And then we have our videos table has a list of, let's see, we're joining on an audience ID. So we got to add a column to the videos table for a hook ID. It's a big deal. You spend half your time just working on changing your schema to do this next operation. Graph database. In a Neo4j database, all you do is just run a query with a new node type, and it creates it on the fly. You create a new relationship between that node and a video, and boom, you have a hook associated with a video. Any video that you can infer a hook from, you can just quickly add it immediately. And we can compare this query this is a cipher query for our graph database, where we have a normalized fact that's connected to a regular fact that's connected to a video, and make sure we filter to where GMV isn't null. We can do our aggregations here after all of this very performant join logic happens. It's not a join in this case because it's a graph database, but it is analogous to that. And run all your aggregations, and here you have it, order by GMV descending, and boom, you see that the top audience fact, maybe moms, pops up at the very top of your list for this stain remover. And hey, this is working really, really well. If you wanted to look for what audiences am I not connecting with, just change the source to ascending, and you can see who you really could think more about your strategy for marketing. And then when you want to change this to look at hooks, you just switch out normalized fact for normalized hook and fact for hook. And there you go, you're done. Literally 1 or 2 line change in your query, and it just works. So very flexible, very helpful to be able to pivot, especially in marketing. When you're trying to take data and make it into something you can make decisions on, you get a lot of questions that the engineer probably didn't think about until the marketing guy asks, hey, I want something that could tell me this. And you're like, I'd never thought of this before. If you need to go make a whole migration, spend like half a sprint on preparing it to answer this marketing guy's question, you're like, whatever he's working on, he's already just decided to go back to his intuition and maybe go off vanity metrics or something. If all you have to do is change two lines in a query, and you can quickly just say, all right, here you go. I just deployed a change in 5 minutes. Let me know what you think of this. You're gonna keep their attention a lot more. It's gonna be a tool that can actually be used a lot more practically, and it's something that's gonna actually get usage that way. So we can look here at some examples of graph database queries and results for this schema. So this query is looking for videos that sell a specific product in a specific category where the GMV is above 5,000. We return the video, we return the sell relationship, the product, and the category. and we're ordering it by GMV. So we don't see the rows for this. So we don't see the actual GMV values in this particular visualization, but know that that is available in this schema. And we can see this is a given category for health in this graph. So there's a health category, and this is a TikTok shop category that you list your product under. So this is not an inferred relationship. This is very like deterministic, like empirical. It belongs here. At least someone else decided it belongs in this category. We've got different products here, like different GLP, probably supplements. We've got gut health supplements in here. We've got various nutrition supplements. It looks like we do have some issue here where maybe our data could be a little cleaner, where we see this video as saying it sells 2 different products, but it looks like the very start of the product name is the same. So you can probably work on the like merging duplicate products together a little bit, but that's okay. And we can see these are all the video titles. These blue ones are videos. So for example, we have a video by Anne something selling a yogurt maker, and it's in the category of household. And we know for all these videos, they moved over $5,000 of GMV. Similar thing for pet supplies. We've got 3 different videos selling 3 different products, and we could compare, if we were to look at that row analysis, we could see the actual GMV and how these 3 products compare to each other. Right, so this is a visualization that we have built out on top of this whole graph relational system. So we can see a hierarchical view of categories. This is from our normalization process, where we actually normalize it into a category, a hierarchical category, so that we can say, hey, this is a large category that will include many, many audience facts. This one that you see selected right here, you can see it only has 3 audience facts, and it looks like they definitely should be clustered together because it's all centered around people who are interested in egg prep, whether that's worded as egg prep solutions or an enthusiast or a egg prep gadgets. Those all fit under the same category for egg prep. And we can see that this one has, let's see, looks like we have $25,000 of GMV moved for egg prep enthusiasts, and 954 units that went out through videos that were targeting egg prep enthusiasts. Shout out to all the egg prep enthusiasts. Hope you feel seen. This is exciting stuff. So, and then it's like we mentioned earlier, it's very, very easy to shift to different video attributes. You want to analyze hooks, very quick to do. You just add the new node type, new relationship to the video, and you swap out 2 lines in your query, and you're good. The development effort for this, you're going to spend 90% of your time figuring out, excuse me, you're going to spend 90% of your time figuring out how to classify whichever video attribute you're interested in. Whether you're interested in something about the presenter, like, hey, what style does this presenter have? You can spend all your time analyzing, all right, how do we classify different styles that these presenters or influencers have? Like, do they like wearing turtlenecks? Do they like wearing long sleeve shirts, short sleeve shirts? And you can deep dive into, hey, what type of shirt for this influencer moves the most GMV? And maybe we want to say, hey, when we're reaching out to new affiliates, we can just tell them, hey, for some reason, people interested in this egg cooker like turtleneck shirts. I don't know why, but you would know that if that was the case, and you could tell that to affiliates that you're reaching out to, because you want to give them every chance to succeed. And you don't have to spend hardly any development time getting just getting those insights surfaced through the dashboard, you spend most of your time just figuring out, all right, how am I going to classify this? What's the most helpful way to classify this? And if the marketing guy comes back and says, hey, we actually want to talk more about formal versus casual, then you spend your time actually figuring out what does formal and casual mean instead of figuring out, okay, how do I change my database migrations to make that actually work, right? And then you can also track relationships between different attributes. Like maybe you want to check style of the influencer against target audience instead of just ranking styles against each other. So you can see what's the best combination of style and targeted audience in a video. And you can just very empirically see by GMV, this one does the best. And maybe you'll find a very clear winner, and maybe it'll be a very close tie. But you can find that out pretty quickly. This all starts to sound a lot like reinforcement learning, right? You have an agent, which up to now in our examples has been a human, and an environment and a reward function, right? We've set up an environment that can be very easily interacted with programmatically, right? We have a graph database. AI agents love graph databases, which is something that's been covered here a lot. You give this to an AI agent and you don't even have to implement a reward function because actual humans will be your reward function. Real people will watch the videos and decide, do I actually want to buy this product? If yes, then our recommendation system did a great job at recommending what content to film and focus on. If it doesn't get any sales, it knows, hey, that one didn't work so well. So we've got this nice feedback loop. You start off, you have to get a certain amount of inferences ready to go to actually get something useful out of it. You analyze the combinations, recommend a strategy, start posting videos based off that strategy, and then you analyze the performance of those new videos. And there you go. It's a cycle. We've got a giant feedback loop for all of that. As far as the impact of this, it's currently very high risk and intuition driven to work in this TikTok space as far as affiliate content goes. Our system is going to take that and make it at least something that you don't have to do so much of a gut feeling to go off of. And then traditional SQL joins are going to be a lot more expensive computationally. If you leverage Neo4j's graph traversal, it becomes much faster and something that you could actually hand off to a non-technical person and they could get helpful insights out of, and their attention span is going to stay on par. And yeah, it really quickly opens the road for creating something more automated for content strategy as well. Thank you guys so much for coming to our session. Feel free to message us on LinkedIn if you have any follow-up questions. We'll also be looking in the chat for a little while after this to answer any other questions that may come up. But thank you very much.
Thank you. Yeah, the question on GMV is like the gross merchandise value, just for your information. Thank you.
Yeah, so no shipping costs included, just how much did they pay for this item.